The cross product of two vectors A and B is noted like this: A times B, or like this. And the majority of the books using this notation on the left. On the right, it's old notation used in some books or of math or physics. Okay, definition. The cross product of two vectors v1 and v2 is given by the determinant ijk, x1, y1, z1, x2, y2, z2. The order is important. So the first vector is v1. So I have here the first row here for v1. Okay. So to calculate this determinant, you will take plus minus plus I times the determinant obtained after deleting the row and the column of I. So we will have this determinant times I. So here, this is the determinant, plus the second vector minus j times the determinant after deleting the row and the column of j, x1, z1, x2, z2, it's here. Then plus k times determinant of x1, y1, x2, y2. If we calculate, remember that any determinant like this, a, b, c, d, it's ad minus bc. So y1, z2 minus z1, y2, etc. So this is the formula of the cross product. Exercise, find the cross product of I times j. I is 1, 0, 0, j 0, 1, 0. So we will write in blue I here 1, 0, 0, j 0, 1, 0 in green. Then after that, let's calculate. So we have I times 0, so 0 I, and minus j times 0 also, so minus 0 j, and for k, 1 times k. So this determinant here times k, so plus 1 k. So the final answer is k. So we have I cross j, the answer is k, and we can verify that j also as another exercise, j times k, the answer is I, and k times I, the answer is j. So if we take the inverse, j times I, it will be minus k. We can verify and calculate, repeat the same solution as here. K times j is minus I, and I times k is minus j. Okay, there is a nice method to remember these three formulas. These are so important formulas. So let's write like this: I, then j, then k, then repeat again: I, j, k, etc. So if I take the first formula here, I times j equals k, so I and j will give me k. Then this formula here, j times k give me I, j then k give me I. The last formula, k times I give me j. Let's write in green, for example. So if I take k times I, give me j. Like this. We can remember these three formulas. Theorem. The vector v1 cross v2 is orthogonal to each of v1 and v2. Let's prove this theorem for v1, for example. Let's prove this part. To prove this, it's enough to prove that this product dot product equal 0, number 0. So to calculate this product, let's suppose V1, X1, Y1, Z1, and V1 cross V2 here is the determinant given here. After that, how to product in dot product between two vectors? Take x of the first vector times x of the second vector. So x1 is here times x of the second vector is it's I times this determinant. Okay, so it's this one, this part. And we'll continue. After that, we can write this as the determinant, like this, if we, to verify why this is correct here. Why this is correct. If you calculate x1 times this determinant, so it's this part here. Okay. The other one, minus y1 times x1 z1, x2 z2, it's this part here, etc. But here, because I have the same row here, the first and the second row are the same, so the answer will be 0. Now, this dot product is 0, give me that the vector V1 is orthogonal to V1 cross V2. Using the same idea, you can prove that also V1 cross V2 is orthogonal to V2. So now let's suppose that V1 is sketched like this in black and V2 in blue. So the cross product in red here, V1 cross V2, will be orthogonal to V1 and orthogonal to V2. So it's orthogonal to the plane of V1, V2. So the cross product, V1 cross V2, is orthogonal to the plane of V1 and V2. And it's satisfying the right-hand rule. What is the right-hand rule? We can understand it like this. If we sketch a man like this, let's suppose that the man is like this. So where is the right hand of this person? It's this one. So this is right hand. Where is the left hand? Let's sketch it in blue. This is the left hand. So if we take this vector R cross vector L, so the direction of the answer is R cross L is this vector here in this direction. So this is the direction of R cross L. So this is called the right-hand rule. In particular case, if the length of V1 is 1, length of V2 is 2, so the length of this vector will be also 1, and I know the direction and I know everything now about this vector. This is the next theorem. The length of V1 cross V2 equal to length V1 times length V2 times sine theta between V1 and V2. So in particular case, if I suppose that theta between V1 and V2 is 90 degrees, so if I suppose that V1 orthogonal to V2, so sine 90 is 1. So length V1, V2 equal length V1, length V2. So if I go back, so if I suppose in particular case that it's orthogonal here, so, and if I suppose that the length here is 1 and the length here is 1, now the length of this vector is also 1 because it's length V1, length V2 sine 90. And I know the direction and I know the lengths and I know everything about V1, V2. For example, if V1 I, this is I, for example, and here the vector J, so this is the vector K. Let's go back to our theorem. After that, we know that the area of triangle, of this triangle, this area is given by the length of the the product of these two lengths in blue times sine theta times a half. The area of triangle equal, if I call this length A, this length B, so what is the area of the triangle? It's a half AB sine theta. So this length A, this length B, so A times B times sine theta times a half will give me the area of the triangle. Without a half, the area of the parallelogram constructed by these two vectors. Exercise. Find the area of the triangle OAB where O0, 0, 0, A, 1, 2, 3, B, 2, minus 1, 4. Let's write the vector OA. What is the vector OA will be? It's 1I, here 1, here 2. So 1I plus 2J plus 3K. Now the vector OB will be 2I minus J plus 4K. Now the area, before calculating the area, let's calculate OA cross OB. How to calculate this product? So it's determinant of here I, J, K, then 1, 2, 3, the first row, second row, 2 minus 1, 4. So let's calculate I times 8 plus 3, so it's 11I. So minus J times 4 minus 6, so minus 2 times minus plus 2. And K times minus 1 minus 4 minus 5. Okay. So this is OA times OB. So what is the length of OA times OB plus OB? So it's root of 11 power 2 plus 2 power 2 plus 5 power 2. So it's root of 121 plus 4 plus 25. So it's root of 150. Okay. So we can write this as 5 root 6. Okay. So what is the area of the triangle? Using the formula, it's half of the length of OA cross OB. So it's 5 root 6 over 2 units power 2. Let's take these remarks. Remark number 1. The cross of V1 V2 equals minus V2 V1 cross. Why? Because if I calculate V1 cross V2, if I suppose V1 X1 Y1 Z1 X2 V2 X2 V2 X2 Y2 Z2. So here the first row X1 Y1 Z1 for V1. Now using the properties of determinants, if I change these two rows, this determinant will be produced by minus. So I can write minus and x2, y2, z2, x1, y1, z1. But this term is v2 cross v1. So v1 cross v2 equal minus v2 cross v1. In particular case, I, for example, times j equal k, but j cross I equal minus k. Example. Remark 2. V cross V equal vector 0. Why? Because V cross V length will be length V times length V times sine theta between v and v. So sine 0. And sine 0 is 0. So the answer is 0. 0 is the length of the vector v cross v. You know that any vector, if the length of the vector is 0, this is equivalent that the vector is 0. So this gives me that the vector v cross v is the vector v cross v equal vector 0. Remark number 3. If v1 cross v2 equals 0, vector 0, this is equivalent to v1 parallel to v2. Because if we suppose that v1 cross v2 is 0, so also the length will be the number 0. So length, this is equal to length v1, length v2, sine theta between v1 and v2 will be 0, but I know that the vector v2 is not 0 and the vector v1 is not 0, so the length is not 0. So this is equivalent that sine theta between v1 and v2 is 0. So this theta will be 0 or pi. It's 0 if they are in the same direction, if v1 and v2 in the same direction and parallel. But it's pi if v1 like this and v2 in the other direction. In this case, the angle between v1 and v2 is pi. Remark number 4, we have the property of distribution of cross products on the addition. It's like the properties of number, product over addition of numbers. So I can write A cross B plus A cross C. Property number 5, for any three vectors v1, v2, v3, the vector v1 dot product the vector v2 cross v3, I will write the vector v1 in the first row of the determinant, then vector v2 in the second row, vector v3 in the third row. And the answer is a real number. L, for example, a real number. Property number 6, if the cross product, the dot product v1 with v2 cross v3 is 0, so this determinant is 0, and also now this vector v1 orthogonal to v2 cross v3, because we have a property that a dot b equal number 0 if and only if a orthogonal to b. This property from dot product. So if this is correct now, we know that, remember the sketching here, this sketching. If I suppose v1 and v2 any two vectors, then the vector v1 cross v2 is orthogonal to the plane of v1, v2. So if I suppose that I have vector v3 orthogonal to v1 cross v2, so this vector v3 will be in the same plane here of v1 and v2. So the vector v3, if I suppose a vector orthogonal to cross of two vectors, so they are in the same plane. Let's take this exercise. Are the points A, B, C on a straight line? Let's take the vector AB. What is the vector AB? It's xb minus xa times I, so minus 2i, yb minus ya minus 2j, zb minus za minus 4k. What is the vector AC? It's XC minus XA, so it's 2I YC minus YA plus 2J ZC minus ZA plus 2K. So we remark that if I take this x minus 2, this over the x of the other vector 2, so it's not equal. Now it's equal to minus 2 over 2, but it's not equal to minus 4 over 2. So AB is not parallel to AC. Also, another method 2 to solve this exercise, if we take the vector AB cross AC, it will be the determinant of I, J, K. Then here, minus 2, minus 2, minus 4, 2, 2, 2. So let's calculate. So we have minus 4 plus 8. So it will be 4I. Okay, we don't need to continue. 4I plus something, so it's not the vector 0. The vector 0 is 0I plus 0J plus 0K. So because the cross product is not 0, because AB cross AC is not vector 0, so they are not parallel. AB is not parallel to AC. The last exercise, are the vectors v1, v2, v3 on the same plane? You will use this formula here, that if this determinant here is equal to 0, so they are in the same plane. If it's not equal to 0, they are not in the same plane. So let's write the determinant. So let's write v1 dot v2 cross v3. This is equal to v1 in the first row, 1. Here I have 1 minus 1, 2, 1 minus 1, 2, v2 minus 3, 5, minus 3, 5, minus 6. v3 is minus 1, 3 minus 2, minus 1, 3 minus 2. Let's calculate. So it will be 1 times this determinant. So 1 times the 5 minus 6, 3 minus 2, minus minus 1, because I will write here plus minus plus. So I will take minus times minus 1. So it's plus 1 times determinant of minus 3, minus 6, minus 1, minus 2. I will take these numbers. Finally, plus 2 times determinant. I will take these numbers now. So it's minus 3, 5, minus 1, 3. Let's calculate. So it's minus 10 plus 18, so 8. Plus here 6 minus 6, 0. Now here I have 2 outside plus 2 outside times minus 9 plus 4, 5. So I have minus 4. This is minus 4 times 2 minus 8. So 8 minus 8. So the final answer is 0. So they are on the same plane. Method 2 to solve this exercise. Method 2. If we take 2v1 plus v2, let's calculate this. So it's 2 minus 4, 4, and here plus minus 3, 5, minus 6. So what is the answer? 2 minus 3 minus I, minus 4 plus 5 plus j. Wait a minute, here minus 2, minus 2. So it's here we will have minus 2j plus 5j. So it's plus 3j. Finally, plus 4k minus 6k minus 2k. So this is V3. Yes. So because of this, so V1, V2, V3 on the same plane.